meeting. Okay. So first of all, let me just introduce myself, and then we can continue with the slide, with the course syllabus. Hold on, I missed. Yeah. Okay. So as you can see here, actually I have a brief introduction for myself on the course website. And then I have currently working at BlackRock as a financial modeler, and specifically focusing on fixed income analytics. And then previously I have worked at Morgan Stanley and a company called Citation Shares, developed multiple business predictive models that solving business problems. And then I had a background from RPI, Rensselaer Polytechnic Institute, on the operations research and statistics, and then originally came from China. I got my undergraduate degree in China. So with that being said, if you have any questions, feel free to ask me, send me email, or try to post questions from the Blackboard system. So before we start, actually, I do want to quickly. I know that you guys already did some work on the introduction. So um, if um, if you could, let's take a look at. Hold on. Take a look at some of you guys and see. I assume that everybody has already got a chance to do this. So why don't we just go through this list rather quickly, each of you. Go ahead. Matthew? Is Matthew here? No, doesn't look like so. So let me say Matthew is currently living in Queens, working in the healthcare industry at the moment, and in the main report writer for my department, and work particularly with the financial aspect, the denial management for my hospital. Actually, looks like there was previously, in a previous cohort, there was a student, I couldn't remember exactly his name, is doing exactly the same thing, has hospital on the healthcare industry. If, oh, you don't have a mic, that is Matt, who is trying to, anyway, that's okay. I'll just explain your background here a little bit. So I remember that there was a student the year before, I believe. His name could be Rohan, but I'm not 100% sure. So if you want to catch up with him, that would be a good. I can try to figure it out as well if you're interested in that aspect. So next one, Chirag. You want to introduce yourself a little bit? If you don't have a mic, let me know. Doesn't look like your mic is working. But anyway, so you have 10-year experience as a Java programmer, and you're interested in learning more on the data analytics. Looks like that's great. And 605 is the computational mathematics. Is that the one? I would think so, right? So that's great. So welcome. So just want to mention that 605 is not as rigorous as 609, in the sense that you have to spend a lot of time for 609 because it just happened that it has more diverse topics and it covers a lot. So make sure that everybody in the class is on the same page, that be ready for spend more time on 605 for sure. Okay. Next one, Raj. You want to introduce yourself here?
Yeah, thank you. Hi, this is Raj. I am currently holding a position as a global head for enterprise architecture and digital transformation initiatives across all of retail and CPG customers for one of the large MNC. It's for Tata Consultancy Services. As part of my job, I provide thought leadership and mind sharing sessions with CXO level. So we typically do mind sharing sessions on digital enterprise digital strategy, enterprise data strategy, and application revamp, modernization, and transformation. As part of this whole learning session, I would definitely like to get updated my skill set in data modeling by applying the mathematics that I'm going to learn in this session. I'm sure I will. So additional information about me could be found in my LinkedIn profile. Thank you very much.
Thank you, Raj. So definitely would be able to learn a lot of math modeling techniques in this course, specifically some optimization, some regression, and some simulation. And when we actually started developing this course, there was no separate course called simulation, but now we have a more in-depth simulation course. So this one of the sections in this course actually serves as introduction to a simulation. Hopefully you would enjoy the class on this aspect. Okay, next one, Jason.
Hi, hello. Can you guys hear me?
Yes, we can. Go ahead.
Hi, good evening. My name is Jason Joseph. This is my second year in the program. I currently reside in Guyana, which is found in South America, kind of sandwiched in between Venezuela, Brazil, and Suriname. It's a tropical country, so the most I have to worry about is most likely rain and sometimes flooding. But apart from that, I'm a programmer at the military here, the Guyana Defense Force. I've been a programmer for roughly 4 years. And through my job and the wealth of information we collect, that was one of the key motivations for me pursuing this master's because the data is just sitting there, and it'll be interesting to do something fun with it. Other than that, if I can help anyone with anything, feel free to reach out, and I look forward to a good semester. Nice meeting you guys.
Welcome. It's glad that we have an international student who actually is real international. I think this is the first time actually I see someone who actually live overseas, but actually attending the program so far in the past 2 to 3 years. Welcome. So next one, Musu. No, doesn't look like he's there. Let's say he is ex-Oracle and worked in Oracle 15 years, left for startup, 15 lead informatics. I'm a corporate technology person, and you can find me in LinkedIn. He's trying to learn data analytics and to position myself as a cloud application expert with data analytics skills. Head of technology and product innovation and product development. Okay, interesting because that we see him here, and then we also saw the previous year there was a gentleman who was having his own startup as well, and doing some financial related predictions. You Can you hear me okay? Now it's better, right? I apologize. I forgot to put my mic closer to me. I apologize for that. So V Informatics, this is the Musu's startup. So if you got a chance, definitely, I definitely would go ahead and take another look when I get a chance. All right. So next one, Edwick.
Yes, my name is Edward. I started the program in fall 2015. This is my second year. I live in Wisconsin, working for UW Milwaukee as a database administrator, doing some work on SQL Server. And I hope to learn more about mathematics in this class. Thank you.
Okay, welcome. Srinivasa, go ahead.
Hi, good evening, everyone. This is Srini. Um, Glad to be on the class. This is my second year. Um, Last semester, I did 2 classes. I see some familiar names here, so um, glad to be part of the team again. My current profession is I'm a consultant in the SaaS cloud application space. I work for Accenture, and I basically work in the sales, marketing, and call center areas, primarily in the CRM applications. Um, I hear and learn a lot when I work with various clients about how they can best leverage the data that they have across the enterprise. And there's a lot of talk about big data and Watson comes into the conversation sometimes. Um, so the best way to kind of leverage the data is to make use of the data in the enterprise and kind of doing the processing, machine learning, and using some models, which I'm sure we'll learn a lot in this class, and come up with some predictive solutions that might help the client. So that's my area of interest, and hopefully this class and this program would give me all those inputs.
Thank you. So I just actually want to mention one thing that this mathematical modeling course that we are trying to position ourselves as introduction for the rest, which is a core course that can be served as a fundamentals for the rest of the other courses such as predictive analytics, such as machine learning and data mining. So in this course, we try to introduce a lot of fundamental skills that can be used for later courses. For example, optimization, machine learning, there's a famous method that's called support vector machine, which is one of the more popular clustering and regression type of methodology. Itself is a nonlinear optimization problem, which will be covered in our class this semester. Okay, so next one, Dan. Is Dan here?
Yeah, I'm on.
Go ahead.
Hi everybody. So I'm a software developer. I've been doing Java development since about 2000. Actually, that's why I included that link to Spark. Kind of interested in that lately, sort of the data science JVM-based language. But yeah, I've been doing software development for a while now, and it's been sort of lacking the real problem solving and analytics. So I think the second that big data and data science started getting big and hearing about it in the news, I just wanted to get into it. So yeah, I'm taking my 6th and 7th classes now, and yeah, looking forward to it.
Okay, great. So on this aspect, I want to mention that it happened that in my current work, uh, in my current day job, I'm working on using Apache Spark as well. And then apparently because I'm on the analytics end, so we use Stack SQL, Spark R more frequently, being given that Spark itself, Scala itself is already set up as a platform that we can use. Apparently, Spark is actually gaining a lot of more momentum since last August, and then many of the concepts that initially that was designed for the MapReduce uh, type of algorithms is being replaced nowadays in Spark paradigm. So I'm sure that it's so far as we can see, it is potentially could be a very promising technology for sure.
Yeah, that's what I'm hoping. I'm hoping that's in my future, but we'll see.
Sure, great. So next, Yadu, is Yadu here?
That's me.
Go ahead.
Yeah, hi, my name is Yadu, and prior to starting my MS in data analytics, I was working as a design engineer, as a product design engineer in a startup company located in Bangalore, India. And the reason why I left the company was because most of my work ended up involving data entry, data organization using Microsoft Excel. So that's what motivated me to pivot my career from engineering and design to data analytics. And so far I have completed 604, 605, 606, and 607. And through this course, I hope to learn more about mathematical modeling, and I do look forward to a fun learning experience in this course.
Okay, great to have you here for this course. And as you mentioned, I605 do have some elements that already covered. And here we're taking a different venue and using different methodology to solve some of the mathematical problems.
Right.
Okay, Yu Qing, go ahead. Yu Qing is not here. Okay, she's not here. Live in Queens and from medical research background. In fall 2016, I have come. I started program in fall 2016, probably 15, right? Have completed 6 courses: 624, 604, 621, 604. Machine learning and data modeling. Get a job as a data scientist would not be easy. I hope this course will build me up a very strong mathematical foundation. I just read one article today would like to share. Article is regarding data storytelling. Okay, great. So this is something that definitely you guys should take a look. Something that's relevant to how you can build up a skill set that might be useful. I will definitely take another look after the class. Hopefully we can go back there. Okay, sure. So James, is James here? Okay, go
Yes,
ahead.
can you hear me?
Yep.
Hello?
Yes, we can hear you okay.
Okay. Yes, I've been enrolled in the program since January. So this is my second full semester. I completed 605 in the spring and completed 621 over the summer. My background is primarily management consulting and structured finance. I do have a couple of other master's degrees, one in computer science, but I haven't done any programming since very early in my career. So, but most of the work I do is as a management consultant, and just like I think it was Sri who said, a lot of clients have a lot of demand for more expertise in the fields of analytics these days, and that's primarily why I decided to pursue this field of study for the time being.
Okay, good to have you here. Definitely would look at what you have shared here for this particular article. Facial recognition algorithm.
Oh, this is actually this is an article about overfitting. So
Okay.
I've actually reposted it in the week 3 discussion because I think it's a very timely and apt discussion about some of the problems that the facial recognition algorithms that are out there today face. They're basically all of them suffer from significant overfitting problems. So you can all read the article and get smarter about that if you want.
That's great. Thank you. Thank you for sharing. And I hope actually every one of you, after this, please take a look at some of the links that some of your fellow students actually shared. So I'm not sure if this is complete, if everyone actually get a chance to speak. If not yet, looks like everybody actually. Anyone online that who haven't posted on the introduction set yet? Not yet. Looks like everybody actually talked. So let's just continue with the course. So the first thing that I want to share is let's discuss a little bit about the syllabus. And then if you have any questions, feel free to ask. Okay, so as you probably already know, this is course is called the Mathematical Modeling Techniques for Data Analytics. And then as the name actually indicates, we're trying to have a solid understanding of the fundamental mathematical modeling techniques. And then as a prerequisite, which is data 600, data 605, and data 606, especially data 606, you should have basic understanding of statistics and probability, as we do need those basic techniques to understand all the different branches that we are going to explore and the modeling methodologies that we are going to explore for this particular course. So in this particular course, what we are going to learn is really include difference, how we can use mathematical techniques to represent complex system, and then include different system differential equations, linear programming, nonlinear programming, and algorithmic search methods for optimization and integer programming, which is one of the methods that will be used for integer programming is called branch and bound. And they use this for all of these mathematical modeling techniques. And then if you don't know anything about optimization, hopefully linear programming and nonlinear programming can give you some opportunity and exposure to understand a little bit more about optimization, because a lot of relevant problems are actually optimization related problems, such as I just mentioned support vector machines is an optimization problem. Regression itself is an optimization problem as well, which is many people probably didn't even realize. Hopefully, later in the course, you will be able to understand this concept better. So what we're trying to learn, including linear programming, try to understand simplex method, which is the LP solver method, and then understand duality, be able to perform sensitivity analysis. That's a key for linear programming. And then you will be able to formulate integer programming models and understand and apply branch and bound technique. And for nonlinear programming, you would know how to use second order condition and apply to quadratic programming, and then learn steepest descent method, which you have already studied some in the 605. And then you can learn how to use commercial and free optimization tools. In this particular case, we're using one of the packages in R because we have been focusing all the programming in R, so we used one of the one of the solver in R. And then hopefully you can gain a good business understanding, apply frameworks and process, build out data analytics solutions from understanding of business goals. And then you can have solid fundamental data programming skills, solid fundamental math and statistics skills, and data understanding, data preparation, optimization modeling, and model implementation and deployment with, of course, hopefully, at the end, we have a comprehensive project, and hopefully you can summarize your results and present the results to the team. And here is the key. So we would have participation is really on the online discussion forums and communication with fellow students, which is 14%. I actually consider it as free because if every week you can post something on the discussion board, you would get that 14%. So I want to open a window to show you. You probably already started doing that. Is right here. So if we go to discussion board, every week we have discussion. Week 1 have a discussion topic, and week 2 has a discussion topic as well. So I really want to see one thing, that anything you can start a new topic. It's also fine that if you reply to whoever presented here. So the objective is apparent, right? The main purpose is not to say that you post something. The main purpose is to take a look at other students. Of course, post something is important, but on the other end, look at other students, what they're posting, and try to communicate with all these students. Hopefully, we can all together to learn something new. That's the objective for the discussion forum. Hopefully, you get the idea, and then we could all work together to learn something new from each other. And then the second component is assignment 14. Apparently, it's a lot. And essentially almost saying that every week you have one homework. And good news is you only need to submit 3 selected problems of your own on the assigned list. So for example, this week probably have 4 or 5 questions. You only need to finish 3 of them. And then I can give you extra bonus points that's up to 15%, meaning that if this homework worth 100 points, potentially you could get up to 115 for that cost and for that homework submission. And then I only randomly grade 7 homeworks. So the non-graded homework will be given 100% grades. So if I don't grade homework 1, for example, but I'm still going to post the solution for homework 1, and then you need to review the solution for homework 1 yourself. So even though you get 100% for that homework, it doesn't mean you actually do 100% correctly. That's why I hope you can do that, your homework, do some homework after you submit the homework so that you understand what the solution is. Of course, for the ones that are actually great, you would specifically know where you didn't do right or which part you can actually improve. And then that actually gives us 56%, essentially saying that each homework is worth around 4%. And then we have a cost project that's worth 30%. In this cost project, it breaks down by multiple submissions. First submission is by the end of week 9, you're going to have a project proposal. And the proposal is you just need to submit something, a paragraph, to explain what you want to do. And then on week 9 and week 10, let's say specifically on week 10 and week 11, we have mutual communication to understand your draft proposal, and then I can provide some feedback, and then hopefully by the end of week 11, you have a final project proposal. Potentially, week 9 submission would be the same as week 11 proposal if we don't have a lot of change in between. And then that each of those submission would be worth 10%. And then project presentation slide is due on that particular day that we are going to have the cost presentation. And the presentation itself starts on December 14th, starting at 8 p.m. Because we don't have a large group here, we only have 12. Hopefully, if we have 6 to 8 groups, I'm sure we can finish it by the end of the session around 9:30, let's say. A little bit after 9, which would be around 9:30, hopefully. So be prepared for that presentation. It's probably going to be a little bit late for that day. And then for final project, that's going to be due on December 21st, which is Sunday, 11:59 p.m. It is worth 50% of the project grade. And then I do have some specific discussion at the end of this syllabus on what we are expecting and what type of project that you need to come up with. There are 3 options. You can take another look and try to get familiar with it early in the process. And then I also have this project schedule here again, and how you form your team, and what the presentation would like, and what type of report I'm looking for. Apparently, I'm not looking for something that's really long. If it's 5 pages, that would be sufficient, maybe less, as long as you discuss the problem sufficiently well. You want to have an analysis of the problem, discuss the methodology you used, detail of the methodology, and the findings from the project. Are they different from your initial expectation? If different, is there any reason that actually happened? And if it's not, then what's the potential, and then what's the insights that you actually get from the project? And at the end, if you can conclude to kind of give us some sense that how you envision that that analysis can be further improved. So ideally, the project is coming from a real business problem or coming from some real problem, which is the option 2, actually. That's more preferred. Apparently, if you choose option 1 or option 3, it still be okay. So let's go back to this discussion. So after this section, we know that these are the university letter grade correspondence of the range of the percentage. With that being said, this textbook is required, so please definitely get it. Even though it's expensive, you would find out it's worth the price you could sell it right after the class, which still not that it's still very expensive as well. So hopefully that's not an issue there. And then you could have this supplemental texts, which is really for the integer programming part. But for anything more math rigorous, derivation or explanation, if you're interested in, definitely go there to take a look at this um, textbook. And then here, even though it says practical optimization, gentle introduction, it doesn't really, it's not that gentle. It's really a lot of heavy mathematics involved in that particular textbook. Okay, you need to install R for sure, which I'm sure you already have it. And let me know. Send me an email anytime if you have questions. And also post in the ASEAN instructor from the Blackboard if you want. So this is I want to go through this briefly, hopefully very quickly, and then we can go. I do want to cover a little bit on the week 1, week 2, just because we already it's already the second week, so we don't want to lag behind too much. So so what we're trying to discuss for the first 2 weeks is small general introduction, and then week 3 we still continue with some sort of model fitting and experiment modeling, how we can think about translating real-world problems to a mathematical model. So give you a sense on how that could happen, how we do that simplification or abstraction to get into the modeling phase. And then week 4, we're going to discuss simulation modeling, and then week 5 would be discrete probabilistic modeling, in which case you would understand a little bit more on how to get an expected value, etc., from serious probabilistic events. And then week 6 is LP, linear programming, part of the basic understanding of optimization. And week 7, you understand graph theory a little bit, understand how graph theory is connected to linear programming. And week 8, you're going to study decision theory, followed by game theory on week 9. So, and week 10, we have differential equations, followed by week 11, system differential equations. And as you can see here, week 12, we have nonlinear programming. Week 14, we have integer programming. And also week 13, we have graph as one method to understand the math programming. So you can see that week 12, 13, 14, and week 6 are all optimization related, and that comes together. Even week 7, they're coming together. And then on the other end, week 10 and 11 is more related to week 2, actually. And the rest of the more sporadic specific modeling methods. So I really want to another view that we can take a look at this problem in real mathematics course. If you are from an applied mathematics program, then you probably have to learn all of this in 3 or 4 separate courses. But here, what we're trying to do is we're trying to give you sufficient enough so that you understand what is it about, and then when you really need a specific technique, you would be able to do research on your own to find out how to go deeper to understand things better. So that's the whole purpose of this course, and the syllabus actually give you pretty much a very good sense on what it is about. And apparently, you should follow the academic integrity and understand the basic policies that the school actually have. That's pretty much everything. And then the last page, I have all the meetups that we probably will have, at least so far that we planned. So alternate weeks, we would have office hours. Apparently last week I didn't log in. Not sure if anyone actually get a chance to log in. But starting from next week, September 14th, we will start the office hour from 8 to 9. And then if you have any questions, feel free to join, hopefully at the beginning of the process time. If you missed me, send me an email, because majority of the time, if from 8 to 8:15, if I don't really see anybody asking any questions, I may just log off. So you can use the same GoToMeeting link to access the office hours. And that's pretty much everything for the syllabus. We do want to go through the...
Can I ask a question?
Go ahead.
I know at least a couple of us actually have a class on the alternate Wednesdays. The 604 class is on the alternate Wednesdays from 8 to 9. So are you available at any other times for office hours if need be?
So you're asking, so you're saying not just you have a conflict, right?
It's more than just myself. There's a couple of other people in the class here who are also taking the 604 class, and that class is held on during the times when your office hours are
the same time.
Right.
Okay, I didn't even realize, because this time is actually assigned by Rakshana, right? I definitely, absolutely. If you would not be able to join me, if you would not be able to join me at that particular time, send me email. If you want to set up some conversation, we can even have a conference call. Just directly call me on my cell, and then we can discuss some of the problem. Definitely not an issue at all. Or we can schedule some sort of Skype meetings or anything that you prefer. Okay. So any other questions though, in terms of syllabus? Go ahead.
Yeah, I have one question about the homework assignments. You said that we only have to attempt three of the problems, and like any extra problems we do, we can get like 15 extra points. Like, what if we do like every single problem in that is assigned in the homework?
No, actually, here probably I'm trying. It's not. I didn't probably describe it accurately. What I meant was, if you finish everything, if I have 6 problems, you finish 6, you can get up to 15%.
Okay, so
if you only do 1 extra, you probably won't be able to get 15%. You probably get 5%, 3%. I don't really know. It really depends on the quality of the homework that you have done, actually.
Okay, all right.
So in other words, if there are 6 problems, you finish all of 6, you can get 115. And then if you finish 4 of them, potentially you probably get 105. Could be 108, could be 110. It really depends on the quality of the submission.
Well, quality would mean how we present it?
Yes, actually, this is actually a very important aspect that I want to explain. If you do even if you do a math, you do 100% the math correctly, you have to give me some insights, right? You explain, okay, based on this is significant, and then it looks like the impact of this is X, right? You have to summarize the results. In the past, I found rather frustrating in the sense that some students just give you the results, ask me, almost trying to say, here's the results, program results. That doesn't help. I hope that you can explain a little bit. That's a skill set that we're trying to learn here. Not only just to run the program, but also try to explain the results a little bit.
Yeah, I got it. So we have to use some English to explain do an explanation of the results, like tell a story about it, right?
Yes, it can be. It doesn't need to be long, right? It's just one sentence, two sentences, but you got to the point and write out what you think about the results, implication of the results, right?
Yeah, like in every problem, right?
Uh, yes, but of course, for some of them, you may not necessarily need to because it's just a derivation of equation, then you don't really need to.
Okay, all right. Yeah, I got it. I got it, sir.
And also actually specific, I'm not sure on this syllabus I didn't see, but in other places I specifically said even if you don't have time, you don't really want to use computer to finish your homework, you can write it out on a paper, you take a picture, that's perfectly fine with me as well. But do not submit separate files for each problem. If you have problem 1 in Word, problem 2 in a PDF, problem 3 in a PNG, hopefully you put them together as one file, scan them all,
Okay.
whatever you do, and then I can review the whole thing together. That would be a preferred way of submission. But you don't need to type them in the Word program or in any other program that you wish. Of course, you're welcome to, but I don't require you to do that. You could write them out, just use handwriting to finish the homework.
Okay, yeah, I understand.
Okay. Any other questions? Okay. So if no other questions, so let's continue with what we need to cover. We don't have too much time left, but let's at least get through first week's slides, and then we can talk about second week. Hopefully next time I would be able to catch up faster because majority of the time I prefer we cover this week and next week so that when we come to the 2 weeks from now, you would have sufficient enough time to understand, to give you a enough sense on all these specific topics. Okay, so for chapter, for homework 1, which is due for week 1 as well, and homework 2, which is due this week as well. Even though if you haven't got your textbook, you wouldn't be able to submit, send me an email, let me know so that you can get some extension on that. And also for the regular homework, if you know you would have to, you need extra time, definitely let me know. But hopefully you don't delay too much because what happens is for 14 homeworks, essentially saying the first 10 to 14 weeks you have one homework every week. If you got delayed, it's harder to catch up in some regard. So let's take a look at what we are going to cover for the first week. Take a look at the Appendix D, which is a page Appendix to 12, which is some integration type of information that can help you to understand some of the methods that we need to use in the following up sessions, which mainly in the integration and differential equation methods actually. So it has information on use summation, integration by parts, rational functions, partial fractions, and distinct linear factors and a repeated linear factor and quadratic factor, partial fractions. So review those. If you have questions, let me know and then we can discuss. This is college mathematics, algebra, and calculus, which is hopefully a foundation that you already grasped previously and would be able to be used in some of the sections of this particular course. So Oops. So for the first chapter, we really discuss a modeling change with difference equations and approximation change with difference equations, and followed by solutions to dynamic systems and systems of difference equations, which is the foundation for differential equations that will be discussed later in the course. And then let's think about what is really a math modeling process. If you look at this particular chart, let me get a laser pointer. Okay, so from real world data, we can simply find the real world problem so that you can build a model to be as a simplification of the real world. And then you do some analysis, you get some sort of mathematical conclusions, and then you try to interpret the mathematical conclusions so that you have predictions or explanations of the real world. But on the other end, you try to use real world to verify whether your model itself is the correct model that you could use, right? So that's the whole modeling process. And then we're specifically trying to focus on the modeling and mathematical conclusions aspect. And then in the future, when you do predictive analytics, you're really focusing on the predictions and explanation aspect of the modeling, and any of the modeling process. So, and then in this particular session, we discuss the how to model a change, which is really simple. Future value is equal to present value plus that change, which is that delta. And then one of the definition here is two variables y and x are proportional if one is always a constant multiple of the other, so that y equal to k times x. K is a constant. In this case, it's called proportional. And it's rather simple at this stage, but you would say that very soon, in a couple of weeks, we would be using a more advanced version of this definition. So, and then how can we model a change, right? So delta A0 is A1 minus A0, and delta A1 is A2 minus A1, so on and so forth, so that we know n's first difference is delta AN is AN plus 1 minus AN. In this particular case, if we sum up all the deltas, we would see that it would be equal to AN plus 1 minus A0, just because the intermediary A1, etc. has been cancelled in this case, right? So, and then question becomes how you can use a real example, real world problem, how you can use this sort of simple difference equations to model those problems. And then as a graphical representation, just to say that at n period n, the value is an, and period n plus 1 becomes an plus 1, and then delta an is defined as the vertical difference, y-axis difference, which is an plus 1 minus an, and on the other end, on the x-axis, is really the period of the time. One time period, an has a change, delta an, which is an plus 1 minus an. And then even trying to understand mortgaging a home can be simply use this simplification to model this process, which is the bn plus 1 is bn plus a constant times bn minus a specific value, and b0 is really your initial loan amount. And then as time goes on, this b value keep decreasing in a nonlinear fashion, but meanwhile, you're paying, because of the payment, this b essentially becomes 0. So this is actually one of the homework is pretty much very similar to this model, and then trying the purpose is really trying to give you an opportunity to understand how you can use this method, simple model to understand some of the physical phenomena. And then very similarly, which is the sequence is a function whose domain is a set of all non-negative integers and whose range is a set of real numbers. Dynamical system is a relationship among terms in a sequence, and numerical solution is a table of values satisfying the dynamical system, which is really just a definition. And then if we continue how to approximate the change is delta an, which is some sort of function f. And then discrete change versus continuous change, which is straightforward. Here, for this particular example here, on the left-hand side, you can see that as time goes on, every single time epoch, there is corresponding value of p, and then this is an example in the textbook that used Pn plus 1 minus Pn is 0.5 Pn. You can see that this is a linear function because Pn plus 1 equals to 1.5 Pn, which is a linear function. No, that's not quite right. The relationship is not a linear function, but the relationship between the current observation and previous observation is apparently a linear relationship, right? So, and then if you look at next one, that is Pn plus 1 minus Pn equals to this complicated function, and now Pn plus 1 is a function, a quadratic function of Pn. And this method here, we haven't introduced anything about regression yet, even though it kind of already have that sense. But in this particular example, we're still using difference equations to approximate some change. And then in particular, this methodology will be used in another homework as well, in a very similar way for the as what we discussed for the mortgage ones. And then question is, if we solve the problem numerically, what's the difference? And then on the other end, if we use some sort of model, what's the prediction versus observation, and then trying to understand here. And then, so here's saying that how we can try to build a model. You try to look for a pattern, you make some sort of conjecture, test the conjecture, make a conclusion. So the real modeling aspect is really the second step and the third step, how you connect between the conjecture and test the conjecture. Apparently, this conjecture is very much hinged upon the first step, that looking for a pattern. At the end, you have to conclude, understand how to make your conclusion, try to come up with whether it's a valid approach or how much you could validate the model itself. And then linear dynamical system, an plus 1 equals to Ran for r any non-zero constant. Then in this case, ak becomes r powered by k times a0. This is called linear dynamical system, just because the next observation is a linear function of the first observation. In this case, it's a0. And also a linear function of previous observation, as you can see, an plus 1 equal to r times a sub n. And then similarly, we could go through to say that if for a function that is having this particular form, an plus 1 equals to r times a sub n plus b, and the equilibrium value is really A is equal to B over 1 minus R if I equal to 1 and B is equal to 0. Take a look at the derivation of this one, and then you would understand how we can get this dynamic system solution. Of course, in some of these later courses, we're going through some of these details, but because of the time limit, majority of the time we wouldn't be able to. Hopefully, especially for the more difficult ones that you came up with or you saw, definitely let me know, and then we can go through them together. And then nonlinear systems, a(n plus 1 is r times 1 minus a sub n times a sub n. A(n plus 1 is a nonlinear function of a(n). So this is going to be used later on in the nonlinear programming, apparently, just because we know this function is already nonlinear. It has a nonlinear feature there. And then I want to say that, go through some of these examples, and then they're using pretty much all the similar and simple techniques that we just discussed. It looks simple, but it's really more important to understand what's the link between the real problem and the solution, and how that model is doing its job to model the real problems. And then note that some of these examples will be further discussed in later, so if you read, it will definitely help you understand these examples, and then try to pay attention to sensitivity of initial conditions, and also essentially trying to understand the stability of the solution from the model. So meaning that if the initial solution changes, the model results will change. Essentially, the model is less stable than the ones that have more stability, that when you have multiple initial solutions, the model itself gives you the same results. Okay, this is the homework for this week. As I said, you only need to finish 3 of these. Of course, if you finish 4 of them, potentially I could be giving you 115, and it could also be I just gave you 105. It really depends on if everyone else only did 3 and you did 4, apparently you would get probably a better chance to get higher. But don't have too much expectations, in the sense that at least you can get 5 points from this extra one. Let's put it this way. That's that for section 1. And then I don't think we would have time to discuss week 2. So which we would try to discuss next time. Let me quickly see if I could discuss a little bit, if possible at all. Week 2 is actually pretty short in a sense. It really doesn't have a lot of ground. It's more like modeling to understand the modeling process. So let's definitely get through this. It's only a couple of slides, so really quick. So here in this section, we kind of go through this process. So what is a real-world problem and what is a mathematical world problem? So for the real-world systems, it's observed behavior or phenomenon, and on the mathematical world, it's the models, mathematical operations and rules, mathematical conclusions. And then if you look at the left-hand side versus right-hand side, that's really the problem, that if you really want to build something from real-world behavior, you want to get some sort of real-world conclusions, you are trying to use trials to make some conclusions, rather than going through the whole process of modeling, analysis, interpretation, and then you can get some real-world explanations and predictions you are really just coming from the real world behavior, get some sort of trials, get real world conclusions. Apparently, this path is time consuming and less rewarding, and potentially the conclusions could be wrong, right? Because you could just potentially could be only focusing on specific aspect of the problem or phenomena that you have observed. But hopefully the modeling process can help you uh, to have a deeper understanding of the real world data. And then the nature of model, so for based on the nature of a model, we could separate two different types of the things. One type would be a mathematical representation. You can use model construction, model selection to do a mathematical model to understand the phenomena or understand the problem. But on the other end, if you want to replicate the behavior, you could use experimentation or simulation, which is so different in comparing with the math model. Majority of the time, if you could go through a math model path, you don't really want to go through a simulation phase, because simulation is still trying to replicate in the real world, but meaning you have to run the model multiple times, 10,000 times, for example, and then get an average so that you get an average sense of the behavior. But mathematical model is trying to get into the system and use a model to represent a real problem and get a conclusion from there. So apparently, computational-wise, simulation needs more effort, but modeling side, if you modeling using you didn't use the right approach, it could be potentially dangerous as well, right? So if you think about all these different types here, there is a discussion, which is essentially what I just discussed. From the cost perspective, real-world observations probably is much harder to do, and then model-wise, it's less expensive. But from fidelity perspective, apparently, if you have a lot of real-world observations, it has more value in that regard. But your models potentially could be uh, misleading, could have less fidelity to the real world observations. But on the other end, on the flexibility side, mathematical models apparently do have the a benefit that it's more flexible. You can change the scenario, change the data to understand the system in a different way. But the real world, once you don't have the um, luxury to collect more real world data, then it becomes less flexible. So this is giving you a sense on how all these different approach actually be useful for real world scenario. And then here gives you some interaction on how you can construct a model. You identify the problem, make assumptions, and identify and classify the variables, determine the interrelationship between the variables and submodels, solve the model, verify the model, implement the model, and then you maintain the model. And hopefully you can refine this model later in your process. And then it's an iterative nature of model construction. Apparently, it needs long-term maintenance that you could further change or try to improve the accuracy and usability of the model itself. And then you have to make some assumptions. You have simplified the real world, use model simplification, and also you have to further refine the model. And then here it has a list of the points that how you would simplify the real world. You restrict problems identification, try to neglect some of the variables, and then you can set some variables to be constant, assume some simple relationships. But for the refinement, you could consider additional variables, consider each variable in detail, allow variation in the variables. So here, we're trying to give you a sense that there is always um, um, a selection of model, a selection of variables when you come to the model building process. In other words, if for the same business problem, 3 modelers coming to the room, 3 modelers could be coming up with 3 different type of methodology, right? But on the other end, hopefully these 3 models can come up with a similar conclusion. So this modeling using proportionality that we discussed a little bit earlier in the previous chapter, and apparently in many of the physics laws, it already used this modeling using proportionality, which is as conceivably as simple as the difference models that we discussed just now. And also how to use geometric similarity to run to understand, to build a model to understand the data. And let's continue. This is the homework for this week. You can select 3 of these questions. It's actually all rather simple if you review the textbook rather carefully. Definitely let me know if you have any further questions on the homework or anything on the textbook, etc. And we can discuss some of the details as well for those. And then with that being said, this is pretty much that I need to cover today, and I apologize that it's running late for 20 minutes, and hopefully in the future this won't happen again. You have any questions? Feel free to ask now. If not, we probably will stop here. As I mentioned, if you couldn't finish the homework for the first 2 weeks this weekend, let me know beforehand, and then we can figure out something, and then hopefully you can catch up very soon in the coming weeks, the 3rd week or the 4th week. Okay. Without further more information, we can just stop here. No more questions, and you all have a good weekend. Have a good week.